Howdy! Today we're going to talk about the mean value theorem. This is an incredibly powerful theorem in theoretical mathematics, and it has a very simple picture. So the setup is this. Suppose you've got a function f, and it's continuous on some closed interval a to b, differentiable on the open interval. Well, you could draw this secant line here connecting the 2 points where a and b hit the graph. And you notice that there's this point on the graph of f here where the tangent line is parallel to that secant line. Okay? And that's all the mean value theorem states. So, mean value theorem says there is a point C in here so that the slope of the tangent line at C, f prime at C, is the slope of that secant line. So that's the change in y over the change in x. So f at b minus f at a all over b minus a. That's all it says. All right. It has a consequence that we've always expected to be true but never stated because we needed the mean value theorem to verify it. A corollary of this result, corollary just means a small result that follows, is the following. If this function also satisfied that the derivative was 0 everywhere on this interval, then in fact that's because your function is constant. Right, we expected the only graph whose derivative is 0, meaning the tangent is flat everywhere, is actually a flat graph, in other words, a constant function. And the reason why this corollary works, if you write this very carefully, you should be a little more careful than I'm going to be, but let's write it this way because it has all the ideas. So for any x in this interval here, we can still look at the mean values effect on the interval going from a just to x. So that means there is a c in between a and x, so that f prime at c is f of x minus f of a all over x minus a. But we were assuming here that our function had 0 derivative everywhere. So now you just multiply by x minus a on both sides and you get this. But that's the same thing as saying f of x is the same as f of a. And whatever a is, this is our constant. And x, it can be any x, will still be that same value, f of a. And that's why this result works. All right, we'll see some other uses of this in the next video. Ciao.